Was that a good start? Anywho, I got font working a little bit, you could say. I mean, I'm quite proud of that. And it's like blazingly fast. Look at that. It's like instant. My background is in text, of course. Right. But I think there's a bit more to it. Because I don't understand how sizing works. And I do need to clean up a little bit. Like for instance here. And now if also the font is too big, it can crash the program. Because it goes out of bounds of the memory. But that can be fixed. Rasterizing one letter.
This is a function that basically generates a bitmap for a given code point, a given Unicode code point, right? And so what I'm going to do is I'm just going to make a little function here, right? Internal, void. I'm just going to make a little function here that does this exact thing, right? So here is the function that I want to call. It's called stb initFont. We need to give it a place to store the font information, which is just gets declared on the stack. This is stb tt font info. You pass an address to that. And then I need some kind of a buffer, right, into which it will dump that font information, right? I'm sorry, not dump that, into which, or I should say from which it will read that font information, right? So this would be the font file itself.
Right.
Now, we already have a way to do this in Handmade Hero, right? We have the stuff in Handmade Platform that's like debug, read entire file, right? We've got this thing right here. So we actually have a way of pretty quickly doing exactly what STB wants us to do. And again, you know, just not to extol Sean's virtues too extensively here, but again, it's set up exactly the way I want. He's not forcing me to pass him a file handle. He's not forcing me to pass him a file name. He's assuming that I already have ways to read files and that I'm going to want to read files the way I read files. So he just takes a memory buffer of the file. That's exactly what I want, right? It's exactly what I want. It minimizes dependencies. It makes it so that I don't have to work around him. He's working around me, right? And that's really great. Again, another sign of an intelligently made library. It doesn't force its file I/O on you, right? So I can do this, right? I can read the file. So here's our TTF file. I can say I want to take platform, debug, read entire file. And then I can just pass it some true type font name, right? So I don't know what true type font we want to read, but I can, for example, pick one out of Windows. In here, you can see a giant set of fonts, and Arial.ttf is almost always there. So I can perhaps just say we will use Arial for the time being, right? So I will go ahead and do debug read entire file to read out this font file. And then after that font file is read, I will just pass the entire thing to Sean, right? So I'll say, hey, Sean, here's the contents of that file. Work your magic. And that is it. Now, get font offset for index, I believe, is just a thing. You know what? To be honest with you, I don't really know what that does. I don't remember. So let's see what that does. Init font. Let's see here. Init font takes an offset into the data. Given an offset into the file that defines a font, this function builds the necessary cache info for the rest of the system. You must allocate the STB font yourself. Okay. So probably this is just if there's multiple fonts in a file, I would say. So stbtt get font offset for index. I believe that is what that does. Each EF file, TTC file may have more than one font. Each font has a sequential index number starting from 0. Call this function to get the font for a given index, right? And so we just load the first font out of there, but that does exactly what we guessed it would do. If you were trying to load a TTF file that had more than one font in it, this would be your jam. So that would init the font. Then if we want to get a bitmap out of the font, we call stb get code point bitmap. Remember, like I said on the previous stream, a code point, that's the name in Unicode for a particular sort of identifier for a glyph. It's a numerical identifier that uniquely identifies a particular glyph, like the letter T, the Chinese symbol for meat, whatever you want, that. So if I come in here and say, okay, we got font, we're passing it the font that we just sort of initialized, and then what we would like to do is we would like to give it some information about what we want it to do for getting that bitmap, and we want to get back some information from it. Okay, so what is that information? Well, first of all, you can see here that this C, I happen to just kind of know how this works. But again, if you didn't know how it works, you'd go in here to the documentation. It would tell you what it is: scale X, scale Y, the code point, the width, the height, the X offset, the Y offset, et cetera, right? And so what that does is that allows me to basically get back information about what the code point bitmap was that was generated. And the return value is actually the bitmap. And it's literally the bitmap exactly the way that we've been thinking about bitmaps. The only difference here is it's a monochrome bitmap. Like I was talking about yesterday, there's really no need to store colors in fonts because most fonts don't have color information. They're just black and white. So really all you're getting is a 0 to 255, which is about the anti-aliasing of the font. And that's it, right? So we'll start with that, right? We'll do a little thing here where we go ahead and get the bitmap. So this is the mono bitmap, right? Get code point bitmap. This is the font that we want, right? And then we've got scale X, scale Y. If the 0, I believe, if you pass into scale X, just means whatever the scale would be, is my assumption, given the Y scale, right? Now, the Y scale is a little tricky. And the reason for that is because the Y scale is not actually given in units that you would care about in a TrueType font file. I think it's given in points or something like this. And typically we want pixels. And so again, being a pretty cool library, Sean already knew that. And so what he did is he provided a utility function for us, right? Which is sevtt scale for pixel height. And what that does is it says, given the pixels and a particular font, produce the value I should ask you for if I were to want this many pixels tall for the total font height, right? So that's a pretty great thing right there, right? We can just say, like, you know what? We want a 20 pixel tall thing. Maybe since this is a test one, we want something higher, like 128, right? So it's a big old tall letter, and that's fine. So we do stb code point bitmap. That's going to get that for us at 128 pixels tall. We then pass the actual Unicode code point that we want. Now, since the Unicode code point...
That was one of the questions I wanted. Okay, scale for pixel height. So does that mean this is in pixels? 10. What comes out? Like barely readable. This should be readable. Now I can say something.
And the ANSI code points happen to correspond for the letters that we would care about in ASCII. We could just say that the letter that we want is an S for Sean, or perhaps he would prefer an N for nothings. I don't know. I didn't ask him ahead of time, but presumably one of those two. We will ask for an N, And then when we get back our width and height, again, if we go back to the documentation for get code point metrics, get code point bitmap rather, you can see that at the end here, we get back a bunch of information, right? So we can get a width, we can get a height, we can get an x offset, and we can get a y offset. And what are those values, right? Well, the width and height are just how big that bitmap is that comes back, just like we've been working with this whole time. And the x offset and the y offset are this sort of, if you know, he's giving us back a bitmap that I believe that, well, actually, you know what? I don't know. I think he gives us back a bitmap that's the tightest bound bitmap. So it's basically a bitmap that has no empty space around it, I believe. We'll see in a second. And the x offset and the y offset are how you would displace that bitmap to align it with the rest of the font, I believe. Meaning that, you know, if you have the letter A, well, it's kind of a tiny bitmap. And so it has to be adjusted relative to an H, which is much taller, in order to line them up potentially, right? So the y offset might be a thing. That's all. But we'll play around with that in a second. I'm also pretty sure that Sean does top-down bitmaps. So we're going to have a little upside-down fun happening here. And I don't know if he supports, top to bottom, right? So I don't think there's any way to do bottom-up in his system. So we're going to have to do a flip of the result of this. But that's basically it. I think there's a free in here probably for code point bitmap. Hopefully, because he had to allocate some memory for it. Am I misremembering this? Free. STB free. Do not know. Do not know. Feel like it does need to be freed. Don't remember. But I feel like we should know. So get code point bitmap, does it say in the documentation? So I guess, it's right above it. The one place I did not look. So after we do that,
just gonna skip ahead a little bit.
So let's actually see that this worked. Let's actually do something here. Let's translate his bitmap into one of the bitmaps that we could use, for example, like a loaded bitmap, right? So I believe we have a make empty bitmap call here, you know, like this. So let's go ahead and do make empty bitmap, and we'll just, you know, we'll just call this at startup to make ourselves a bitmap of the letter N, right? So let's do that. So okay, we'll put the memory arena in here that we need it to use. I think that's about it. So we'll just say, okay, make an empty bitmap. We know what the width and height would be because Sean told us what they were, and we don't need it to clear to 0 because we're about to actually do all of that work ourselves, right? So we can then step through every sort of pixel here. Every sort of pixel that's in this bitmap, and we can do our own translation to our style of bitmap, which happens to be 32 bits per pixel, not, 4 bytes per pixel, so I should probably say it, rather than 1 byte per pixel. Sean is 8 bits per pixel, right, for mono. So all we would have to do that, again, not particularly tricky. All we have to do that is we take our loaded bitmap that we get here, so loaded bitmap result, and we'd probably just return that as well. There's our loaded bitmap. Let's go ahead and return that here. All we would have to do is be able to access our loaded bitmap. That's, again, pretty easy. It's just the address is obviously just going to be that result memory. In fact, we could actually do this with the sort of the standard row pointer thing that we normally do. We could just say, okay, we've got sort of the destination, and here we've got sort of our row. This is our dest row. That's going to be our result memory, and this is going to be dest row. And we just do part dest++, so writing into the destination. And what we want to do here is we just want to write in essentially white with Sean's value as the alpha, right? So we kind of want something where it's going to be a pre-multiplied alpha bitmap, I guess would be the way to say it, right? And so if you think about what a pre-multiplied alpha bitmap would be, it's just the alpha value replicated, right? Because if we're going to have 1, 1, 1 as the color, and we're multiplying by the alpha value, it's just going to be the alpha value in all 4 channels, right? So really all we're talking about here is doing that pack again, right? So whatever the alpha is, it's just the alpha goes there, the alpha goes here, the alpha goes here, and the alpha goes here, right? Is all that we would be talking about, right? So that alpha value is just going to be the mono bitmap pointer, and we're just going to call that source. Since we read the source in order, and Sean, I believe, packs them densely, it's literally just reading it out one by one. And then at the end here, we just advance by our pitch. Now, we started a half hour late, so we've got a whole half hour to go here. We're nowhere near Q&A, so nobody get too excited about that. But yeah, so there we go. So that
I don't get that bit. This part here. So it's just filling the whole memory with the same alpha value, if I understand correctly. But why? I thought it'd be the other way around. Oh, okay. I think I see what it does, what he's doing.
that's roughly what we're looking at here. Got to do a little bit of cleanup, but I think that's about it. So it looks like these are actually ints there, right? So those are S, 32, oops, not that, but rather that. And I think that is basically it. So let's see, we've got our alpha, that's missing an OR sign. Other than that, we are good to go. So that just alpha replicates out there and produces, you know, the color bitmap for a mono bitmap, right? Nothing particularly weird going on there. So that would create us a bitmap, assuming that I haven't horribly ruined everything by some kind of mistake in the code. And so I'll just go ahead and add in here to where we kind of store random stuff like this. I think we tend to have a few of these sitting around. Test font or something, and I will just make it so that game state test font, right, is going to be made like that, right? So down in here when we first start up the game, after we initialize the world arena, let's say, sure, why not? We'll just go ahead and make the test font like so, and I'll just, sure, use the world arena. Does not matter, do not care, right? So there we go. So in theory, you know, if I haven't done anything horrible, that will at least run. We won't see anything on the screen because we're never drawing anything with that bitmap, but we can rectify that very quickly, certainly. So let's go ahead and there we go. So that's actually creating the bitmap. We're just not running it. So let's go ahead now and run it. And I feel like the right place to put this would be in our head spewing code. That seems like kind of the obvious place for it. So instead of spewing heads, we could instead just spew a ton of, yeah, I mean, a ton of ends. Why not, right? So we've got the particle being rendered here. I'll go ahead and say let's not do that. Instead of doing that, let's go ahead and do our test font, which I assume would work fine. Push bitmap. What is the problem? Loaded bitmap needs to be an address. That's fine. And so let's run it and see how we did. Oh, so disappointing. Where are they? That's just cruel, really, right? When you think about it. So let's go back up here. Let's step into this and see what I did wrong there. What did I call that function? I don't even remember. Make nothing's test. So let's see here. What did we do wrong? Let's step in. Let's step into this guy. Destro plus equals result pitch. This equals destro. That part's correct. The source steps through for every pixel, which is also correct. That looks roughly right to me. That looks roughly right, I would say. So I'm going to go ahead. I don't see anything obvious. So really all we need to do here is just do this, make this bitmap right the other ways around, which would be really easy for us to do, right? We could just step the pitch backwards and start out on the last row, right? We'd just start at, pre-advance the pointer to be starting at that last row, and then we just write the rows in reverse order. That's a pretty trivial way to flip it around. And then, hey, guess what? Our ends are right side up. But it's something to be aware of, right? The STB library has that convention, and so when we do our asset processing, we need that to work. Now that's it. That's all, right? Like I said, this is why when people ask me if you're going to use libraries, which would you use? And I always say the STB libraries, because without fail, they go in clean, they're easy to use, they're thought through. It's a very, very good set of architectural libraries that can really quickly give you access to a bunch of really great stuff without all the headache and problematic aspects that plague almost all libraries.
What else does he do? Merge handmade asset into handmade, adding one bitmap letter to the asset
So now
file.
in here, if we wanted to, we could do something absolutely ridiculous. I don't know that this is really what we want to do. It seems like it might be a little ill-conceived. I'm going to do it anyway, because why not? What I'm going to do is say, all right, there's an asset here that's just like asset font, right? This is a really crazy abuse of our asset system. I don't really want to advocate doing this. I'm just going to do it because we can. Yeah, I mean, we just can. There's really no other way to say it than that. So I'm just going to say asset font, and then I'm going to go into the test asset builder, and I'm going to have it actually operate on these guys. Right? Excuse me. So yeah. So if I come in here for asset font, I'm going to now do sort of the nonsense that we were doing before, this sort of thing, right? I'm going to do that, but I'm going to do it for a font, and I'm going to do it probably in a pretty weird way. I'm going to just generate, like when it does these things, I'll just have a thing that's like right font, I guess.
I think I can skip that. Adapting the font tries the test code to the asset system. What's this? I think I might be able to skip this as well. Asset processing with window fonts. Let's just check it out, see what it's about.
Start recording. Well, in Windows, Windows actually has a bunch of calls for drawing fonts, right? For example, this is the text out function. The text out function is something that can take any string and rasterize it into an HTC. Now, we worked with HTCs in Handmade Hero before. You've seen those back in the early days when we first set up our window and wanted to blip our drawing to it. It stands for handle to a device context. A device context is what they called sort of the context for drawing, the context for doing graphic
Oh, I wonder if it's like the X11. It's opaque. I don't think I can see the internals. It's like the graphics context.
Work in the graphics device interface for Windows. And so what we do know is if we wanted to start extracting fonts out of Windows, we could just call this text out function, and we know that we could get it to draw to an HDC. So the question is just, could we figure out a way to get one of these HDCs to draw into a bitmap of our choosing, right? Like a bitmap that we are okay with looking at behind sort of the back of Windows, if you will, right? Because if we could do that, we can just have Windows draw the fonts, and then we can grab the fonts out of there. And this is the same principle you can follow in just about any operating system. Whatever the thing is they have that would draw fonts, we could just go ahead and use that thing, right? Okay. So there's actually a couple ways we could do this. We could start by doing the absolute slowest way. I believe it's called get pixel. The absolute slowest way, and probably not a particularly good way to go, but we could try it just to make the sort of I don't know what you want to call it, the absolute slowest but absolute simplest way would be.
Let me check X11. Is there anything for font? Oh, there is. Get font part. Font property. List fonts. Load font. Create font cursor. Interesting. Let's have a look at maybe the first one. Where's load font? What does this do? Load specified font and returns its associated font ID. The font name is not in the host portable character encoding. The result is implementation dependent. Use of uppercase and lowercase does not matter. When the characters question mark and star are used in the font name, pattern match is performed and any matching font is used. In the pattern, the question mark character will match any single character, and the star character will match any number of characters. A structured format for font names is specified in the X consortium standard conventions. If X load font was successful at loading the specified font, a bad name error results. Unsuccessful, okay. Fonts are not associated with a particular screen and can be stored as a component of any GC. Interesting. Okay. And the font is no longer needed, call X font, X unload font. Okay, so once you load the font, you can get it through the GC. I do create GC if I'm not wrong. Yep. I'm guessing I can pass. Yep. Value mask, value specifies any value specified by the value mask. Which components the information for the value structure, the argument in the bitwise inclusive order. Valid mouse bits. The create GC function creates a graphics context and returns the GC. The GC can be used with any destination. Drawable, blah blah blah. Used with other drawables such as bad match. How do you pass a font? Bad font. Oh, there's like draw arc, draw line. Interesting. Comes with some methods. X11 create GC with font. Manipulating graphics contexts. GC values. Okay, there we go. Okay, so it's a C pointer to a struct. Yeah, where's font? Mem to zeros of font. I've got to look here. Implementation dependent. What does that mean? I can call. What does load font return? Okay, so I can pass it a font. I need to do anything else. Interesting. And then how do I use the font? Create GC. There's something about patterns. Used in a font name. C dot x load font needs the display. And the name of the font. What if I just put question mark? Will it match the first one? And then here I can pass. Hang on. Create GC. XGC values. Really? Where else is it defined? Oh, here. Let's rename this one. Jeez. Need to restart. My LSP is crashing. And if let's return an error. Error results. How do you? I forgot how you check errors in X11. You just pick something monospace. What's wrong with my LSP? Just gotta check here. Bad alloc and bad name errors. Also, you need to defer and load font. Yes, and it takes the font. Is there an update? Not really. Well, check errors later. It's gonna stop the LSP. It's just slowing me down. Thought I stopped it. Okay. And then what do I do with the font? Maybe draw text. Let's draw string, draw text. Maybe I can close some of these. Don't need this. I'll keep that. Don't need that. Don't need that. Each character image as defined by the font in the GC is treated as an additional mask for a fill operation on the drawable. The drawable is modified only where the font character has a bit set to 1. Specifies the character string, specifies the number of characters in the string argument. Okay, let's have a look. I think I can do it after here. Display window GC. X and Y coordinates which are relative to the origin specified. Drawable and defines the origin of the first character. Okay, let's just draw it. 20, 20. It's fine. Then example. Dot line. What's wrong with the LSP today? X load font. Expected type a C pointer. So I think I can just point to cats. Jeez. LSP is not having a good day today. Value of C int ignored. I think I can ignore it for now. Named color or font does not exist. Let me put question mark. Load any. That's my guess. Where does it look for font names? User share fonts. What's in X11? Let's try source code. Okay, I don't know what's wrong with the LSP, whatever. Named color or font does not exist. Do I have to mention /ttf? What if I just put star? Because, okay, tries to write it. No. Okay, I can't find the font. That's weird. I don't understand. Can I specify the font directory? Query font, what is that? Set font path. Okay, there we go. Okay, it returns nothing. C.exit font paths. Font path. Display. Directories. Not sure. What should this be? What is end directory? Specifies the number of directories in the path. 0. Because I do have font here. Let's just try. Jeez. Okay. // font. Let's try that. Oh, I shouldn't have saved. Expected slice of bytes. Oh, the LSP is off. No. Okay, works again. Set font path. I don't understand the type. Slice of U8. Will that work? Right. What's the type again? Okay, because it's a list of font directories. Slice of constituate to it's like every morning, same story. Why does it require an allocator? Please. Underscore. Wait. This could be the type. Then I think I can do no, that won't work. Seems so simple, but let me check the documentation. Multi-dimensional arrays. Do underscore. Can I do underscore here too? U8. Const U8. Then of font.ttf. No, /font. I think it'd be cast too. I got rid of that. Pointer be a variable, can it? Maybe that will work. Expected type U8 found pointer, const pointer. Oh, because it's got a size. Hang on. I think if I just replace. I don't understand how that works. Clearly. What's the error again? Expected type. I made it a slice of U8. Not frustrated at all. Dimensional strings. Okay, that looks kind of right. Kind of what I need. Okay. So I guess this could be this. Because it's a null terminated. Okay, that makes sense. What does this return? Let's see, and just ignore this for now. So maybe I can't ignore that. Can generate a bad value error. Forgot how to check errors. I haven't touched the X11 library in a while. How do you check errors? Don't think I check errors anywhere. Let me see what it returns. Debug. And that's one. So I guess if result greater than 0. Can generate a bad value error. And I think the way to get edit text. There we go. Get x get edit text. What does it need again? A slice of U8. Display. Results. What else? What's the first one? Length. I don't think this is right. This returns another C. Great. Oh, because it. You know what? Standard debug. Actually, it doesn't fail, does it? Font path. Can I get font path? Yes, I can. There's the number of strings in the font path array. Turns the number of strings in the font path array. Oh, it's a pointer. Okay. Let's see what's in there. Why is it a pointer? Course it returns a slice of. Yeah. Dot. I don't think that'll work. No. Does return a pointer? That means that is a part set. Unbounded for loop. Why is it unbounded? Does it not have a fixed length? Zero to font art. Then NAI, and then this would be font art of I. Oh no. Font art. It's fine, and that's easy to fix. Oh, sorry. Is there a way to make it parse as a string? Okay. That's good. So that means this does nothing. Let's see what's in user share fonts X11 miscellaneous. Whoa. Are these fonts? Is this the font directory? Hang on, what was... No, not that. What were the other fonts? User share fonts X11 type 1. What if I copied fonts font.ttf user share X11 type 1, was it? X11. Was it sudo star? How did you sudo the last? I can't remember. I think it was sudo dot dot. No, star star. I did try to sudo that. Okay, and let's try to. So this really does nothing. Or maybe I'm not doing it right. More likely. Font.ttf. Should be able to find it now. Say build run. Bad name. Named color of font does not exist. Hang on. Is it because it's actually looking inside? What am I doing wrong? Drawstring, draw text. Load font. Is that how you spell it? Area. X11 load font. I mean, at this point, I'd be happy if it just loads anything. Whoa. Why did that work? That just worked. It did. I need the length. That looks much better than my font, to be honest. Whoa. Okay. So if I can set the font part successfully. I understand what this is. Built-in. That apart. Built-in function or structure within the XLM protocol. Okay, I don't know how to load a specific font yet. And I don't know what font it's actually loading. Gotta figure that out. how to set font. Specific font. Not sure where the current is loaded from. At least kind of works. Hang on. Draw string. How do you specify the size of the string? There's also a draw text. Oh, okay. I mean, this makes more sense. If you have like more than one text. Number of items. Okay. Same mouse, fill style, font, sub window. Okay. So there are ways to like manipulate. Characters, number of characters, delta, font. And I think you pass an array of these. X. What was it called again? Draw text. Alright, I think that's, I don't know. I kind of got it to work, but I'm not sure why it works. And it also flickers a lot. And this is this is the font that I wrote. I'd like to figure this out as well. Right now it's just tiny. And then gotta figure out how to change font colors and remove the black background thing. But at least there's a few options. It's better than none. X11 font. It works. Not sure how yet. Alright, it's still a long way away from building an actual debugger. But you gotta show text, right? Step one. Alright, I'll figure the rest out tomorrow. Continue from here. Compatible DC, compatible bitmap. Creating device context. Yeah, I think I'll look through these because I'd like to see how Casey finds the right font. What does he do if he wants his own font? Alright, I think I'm gonna call it today there. It's another short one. Because font rendering is getting the best of me. It's alright, I'll figure it out. I hope you have a good day, and I shall see you back here tomorrow.